Hey guys, so this lesson we're going to just talk about the PPF in a bit more detail and sort of what happens when we play around with some of the some of the different attributes of the production possibility frontier. So just taking back to the example that we put forward last lesson, so we had this slide. We saw that the production possibility frontier of this example had sort of this curve to it. So now I want to sort of go through why it actually would have a curve in real life. And so why would that be the case? So we have a look at the data that we were plotting. We have so as we produce less of x, for the first x that we lost, so we lose 1 here, so 5 to 4, so that's only 1. We made an extra 5y here, but so we lost another 1 here, but here we only gained 4y. So the reason why this is so is because in an economy, certain people or things are more adept to making, say, good x as opposed to good y. So just say if this was movies and y was cars, if we put everyone in the economy to produce these movies, we're going to have people that are normally suited to building cars forced to put on movies just to get that extra 1 here. So if we took that one guy out, he could make 5 movies by himself because he's better at making movies than he is cars. So this is why we sometimes have this sloped curve like this. It doesn't always have to be this way, so we'll just come up with another example here. Okay, so the production possibility frontier could be something like this, so I'll just get some axes. Okay, so it doesn't have to be the curve like we saw last time, but it normally is, so just keep that in mind. But just say it's just a straight line down here. So this straight line just says, okay, so if we have 5 of good x and 5 of good y, if we had, and this is just a -1 gradient, so -1 slope, that just means if we lose 1 of good x, so if we produce 4, we can produce 1 of y. So this is going to be the point for 1. So that's just saying, okay, this good x is worth 1 good y. This is where the production possibility front sort of ties in with our notion of opportunity cost. So here, just in this very basic example, so we have good x and good y. We can have 5, 4, 3, 2, 1, or 0 x's, and we can have 0, 1, 2, 3, 4, 5 y's as the corresponding values. Okay, so what's our opportunity cost of producing 5x? Or actually, let's say, what's our opportunity cost of producing 1x? So we can produce 1 between here and here, and we get an extra 1 out of that. So our next best value at foregone of producing 1 more x between 3 and 4 is losing 1 y. So our opportunity cost is only 1. And we see our opportunity cost actually relates to whatever the slope is of this curve. So our opportunity cost is 1 for all of these points. So our opportunity cost of producing 1x is always going to be 1y. So that's the same no matter where we are. But if we go back to what we had before, our opportunity cost of producing 1x here, so to get to that 4 to 5, so that's only 1x, opportunity cost for that 1x is going to be 5y, because now we're losing 5 of y. But our opportunity cost to go from 3 to 4 is only 4y, so 9 minus 5 is 4. So So what we have sacrificed to go from 3 to 4 is only 4y. So that changes as we go down, and this is why the production possibility frontier has a slope like it does. So we can say that the higher this gradient, so this gradient here as a tangent to the blue curve, that relates to our opportunity cost. So down here, there's a high opportunity cost to go from 4x to 5x, which is here. So that's a high slope, so it's a high opportunity cost. Whereas here, if we just wanted to produce 1x, we've got a fairly low opportunity cost because this is a fairly low gradient. So that's one way that we can see the benefit of having this visual representation of the production possibilities frontier.